NCBM 0324, Section 1.2, Solving Linear Equations in One Variable, Part 6. So we've seen quite a few situations of solving these linear equations with fractions, decimals, parentheses, and let's now look at two special cases or just some unusual things that may happen when we're trying to solve equations. So this is still example 3. Now we're on part I. On part I, we have 3x minus 7 is equal to 3, parentheses, x plus 1, close parentheses. So no fractions. We don't have to deal with those. But I do have parentheses. So I'm going to distribute that 3 all the way through on the right-hand side, leaving behind 3x minus 7 is equal to 3x plus 3. So terms are even combined on each side. Now let's get the variables on one side, the numbers on the other. So I'm going to subtract the 3x. That's going to move them from the right-hand side to the left side. But it also does something a little unusual. 3x minus 3x, well, that's technically 0 x's. So if you want, you can even just say it as 0. Or you can leave it off if you feel comfortable. But what really I have left over then is 0 minus 7. And if I wanted to kind of keep with the pattern, I can add the 7 over. But I still get something kind of weird, right? If I didn't even move the 7 over, if I left it in this way up here, 0 minus 7, well, that's negative 7. And is negative 7 ever equal to 3? Is there any way that this can be true? Or if I went the other way, is 0 ever going to equal to 10? No. These are false statements. So if my variables all cancel and the resulting equal statement that I get cannot possibly be true, negative 7 cannot equal 3, or in this other version, 0 cannot equal 10, if we get a false statement out of this, then we're going to say the equation has no solution. No solution. There is no x that's going to make that left side of my equation equal to my right-hand side. There's nothing to check because I could not find an x value to make it true. Whatever we found, whatever we manipulated, came out to be false statements. So if all the variables cancel, the leftover part is false, it's not true, then our equation has no solution. Which is nice when you can recognize it, right? There's no check to do. You kind of just have your answer a little more freely. Let's look at J now. Let's check out what happens in J. We have 5x minus 5 is equal to 2, open parentheses, x plus 1, close parentheses, plus 3x minus 7. So a lot of x's kind of floating around here. I see parentheses, so I distribute. That's going to leave me with 5x minus 5 is equal to 2x plus 2 plus the 3x minus the 7. And I do have some like terms here. I can add the x's together. That's on the right-hand side. I can even add the numbers together because they don't have x's. So I'm going to have 5x minus 5 is equal to 5x minus 5. 2 minus 7 is negative 5. Okay, interesting. We can see maybe what might happen next. If I try to combine the variables on the left side, maybe in the same step I'll move my numbers over to the right side. We can see how everything ends up canceling. So the 5x's, the 5's, right, the numbers, I'm left with really on the left 0 and on the right side also 0. And again, unusual, but is 0 equal to 0? Is this a true or false statement down here? Well, it's true, right? 0 does in fact equal 0. So when my variables all cancel, and I don't have any more variables, and the resulting piece is true, if whatever's left over is true, then we're going to say the solution is all real numbers. In other words, whatever we plug in on the left side for the x, here, it's going to turn out to be exactly the same what we get on the right-hand side. And that's really, really easy to see and nice to see when we were at this point. Whatever I plugged in for this x here, all the simplification of the right-hand side turned out to be exactly the same. So whatever x goes here, I plug it into this spot here as well. And of course, they're going to be equal. Both get multiplied by 5 and then subtracted by that 5. So any real number we can plug in. Now these two situations are very closely related, right? Notice on both of them our variables all canceled, but the key thing on this first one is that that final statement is false, right? That's what makes the difference. If I cancel off my variables and the remaining part is not true, right? 0 cannot equal 10. That -7 couldn't equal that 3 like I just had earlier. If it's false, no solution. But if canceling everything comes out to a true statement, everything left over is equal, then it's all real numbers as a solution. So closely related, but still very different between no solution and all real numbers as a solution set. So keep an eye out for problems like that.